Hello everyone. Today I would like to start a series of videos on solving LeetCode questions. All solutions will be written in a Golang programming language. Prior to start, I want to notice that I am not a native English speaker, so I apologize in advance for my accent. Let's begin with the first equation named toSum. It is considered as an easy type of question. Here we provided a task description, and we also see here a simple example. We have an array of integers. Integers are 2, 7, 11, and 15. And we also have variable target, which is integer and equals to 9. And our goal is to print indices of numbers which sum of two numbers which sum is equal to target. In our case, 9. And we can get 9 with sum of 2 and 7. And we return a slice of indices. 0 is index of 2 and 1 is index of 7. Okay, it's a simple example, and I think we know the description, we know what is the goal of our equation, and let's begin writing a solution. The first idea that comes to mind is to find all possible pairs until we get a pair which sum is equal to target. It is a brute force algorithm, so in order to find all pairs, we need to write a nested for loop. It is nested for loop, and we need write if statement. If nums I plus nums j is equal to target, we return slice of indexes I and j. If we don't find a solution, a pair, in order to avoid a syntax error, because we should have a return, and we return a nil if we don't find a pair, because a nil is zero value of slice. And let's visualize every step of our algorithm. Here we have an array. I will modify it a little bit. We'll add 3 at the start. We'll move 7 to the end. Okay, let's visualize our algorithm. And first of all, we start with a 3, so I is equal to 0 and nums I is equal to 3. And first of all, we check if 3 plus 2, because j is equal to I plus 1. We check it here. Is it equal to 9? No. Then we proceed and check 3 plus 11. Is it equal to 9? No, it's not. Then we proceed with 3 plus 15. It's also not equal to 9. Then we do 3 plus 7. Is it equal to 9? No. And we then, our I increments to 1 here. And we check the same, but with 2. 2 is I is equal to 1 right now, and j is equal to 2. So we check if 2 plus 11 is equal to 9, 2 plus 15 is equal to 9, and 2 plus 7 is equal to 9. Yes, it is true. It satisfies our if statement. And then we return an I and j. I is, in this case, is 1, and j is 4. It will return a slice with elements 1 and 4. Okay, the time complexity of this algorithm is n square of n square. Let's check, is it work? Yes, it works, and we don't use any kind of memory here, but our algorithm very suffers towards time complexity. Runtime is 40 milliseconds, and it's not actually a very optimal solution. We can do better, and now I will show you the next solution, which will be a lot faster. So in order to implement this solution, we need to create a map with the key integer and the value integer. So key will be an element like 3, and its value will be its index in an array. So it will be the value of 3 will be 0, the value of 2 will be 1, the value of 11 will be 2. Okay, so what we will do, we will iterate over our array for I range nums, and we are going to check if we have an element in a map which is equal to subtraction of target and the current element. And I know it may be a little confusing right now, but let me write and I will explain every step. We will visualize every step, and I'm sure that you will definitely understand what I'm speaking about. So as I told, we need a difference, the target minus nums I. Here I will write an expression like value and is exist, which are returned by accessing a key in a map. So here I want to actually access an element in a map. So I put a key div here, and if I have a key that is equal to div, this element will be true. It says that it exists, and I will access its value. But if I don't have a key which is equal to div, is exist will be false. So I say if is exist is true, I will return I, not I, val and I, because value is index of this key. Okay, let me write and then I will explain. You will understand when we will visualize every step. Else if it doesn't exist, we will save this element int map nums I, and its value is index of this element. If we don't find, we will return nil. Okay, let's visualize every step. So here our target is 9, and we have an int map. Right now it's empty. So we iterate over our array. The first we take 3, and the difference is equal to 9 minus 3 is equal to 6. And we try to access a map with the key 6. So int map 6. So if we have a key 6 in our map, is exist will be true. In this case, our map is empty. That's why we don't have a key 6, and we will get a false. Is exist is going to be false. Okay, and then we save our element, and its value will be its index. So our int map will look like this: 3 with a value of 0. 0, it is an index of this element in an array nums. Okay, the second step. It's 2. 9 minus 2 is equal to 7. We access a map with the key 7. We don't have this kind of element. That's why is exist is false, and it will go in this else. And we create an element 2. An element 2, and its value will be 1, because I is equal to 1. Then I is equal to 3, and we check with 11, which is minus 2, and we try to access with a key minus 2. We don't have a key minus 2, it will be also false, and we will save 11 with index with the value 2. Then we will do the same with 15. Have minus 6 and have minus 6. We don't have a minus 6 key, that's why we will save 15 with a key 3. And right now we will check 7. 9 minus 7 is equal to 2. We're going to check if we have a key 2. Yes, we have. It's right here. Key 2, and its value is 1. So it goes to this. It satisfies our if statement. Is exist is true right now, and we will return a value of this key. The value of this key is 1. Is 1. Well, is equal to 1, because 1 is a value of key 2, and the current index, and the current index is equal to 4. Okay, I think that with a visualization of every step, it should be very clear, and the main advantage here is that we just iterate once over our array, and the time complexity will be linear. I think it is the best optimal solution if we talk about the time complexity. And let's check. Yes, the runtime here is 4 milliseconds, and it's actually 10 times faster than our previous solution. And we have, but the drawback that we have a memory usage here, but I think that actually this solution is a better and more actually useful. So this was the first video. I hope you understood the two methods how to solve this problem, and I would like to receive any kind of comments. Feel free to write them. Thank you for attention. Goodbye.